Welcome back to Remote Sensing Applications using ArcGIS. In this session, I'm going to teach you about something called hyperspectral remote sensing. And the idea behind hyperspectral remote sensing is you can have very narrow spectral bands that are specific to detect certain things. So for example, here we have from a Landsat 8 sensor, the shortwave infrared bands, they're about 10 micrometers in width. And then we have a very wide panchromatic band. And then we have a specialized band called the cirrus band, and it's only 0.02 micrometers in width. So it's a very narrow spectral band, and it's specially designed to detect cirrus clouds. Okay, so if we go back to our shortwave infrared image of the Denali area, we can see here's a cumulus cloud, but we cannot see cirrus clouds. So if we add this very narrow spectral region, it's a band called narrow Swear Denali area. So it's a very narrow region of the shortwave infrared. And that is specifically designed to detect cirrus clouds. So then if we turn it on, so here's an area that has cirrus clouds. So if we zoom in, there's the cirrus cloud. That's a very high altitude cirrus cloud. And if we turn it off, you can see it's not very easy to see in either the broadband shortwave infrared or the near infrared spectral regions. So that's just one example of hyperspectral remote sensing is in Landsat 8 sensor. There's a band that's very narrow and it's specifically designed to detect cirrus clouds. Okay, if you open up an Excel spreadsheet that comes with this week's lab data, the spreadsheet name is Hyperion Valid Bands, and it contains information from a hyperspectral instrument that's on board a satellite, and there's 198 bands. So for example, band 1 peaks at 0.427 microns in the blue spectral region, and we can go all the way to band 198 in the shortwave infrared spectral region. And that peaks at 2.396 micrometers. So if you start a new data frame in ArcMap, we're going to add from the hyperspectral folder this TIFF image, and it'll have 198 bands. And it's from an area along the Tanana River near Tok. Okay, so the first thing we'll do is display this as a color infrared image. So we'll pick one of the near infrared bands to control the red video intensity. So I'll use band 40, for example. So band 40. And then to control the green video intensity will be a red spectral region. So I'll choose band 20 as an example. And then to control, or the blue video intensity, we'll use the green spectral region. So green spectral region, I'll use band 10 as an example. Okay, and then we'll adjust the symbology so it's a 1 standard deviation contrast stretch. Now let's make it 1 standard deviation. Okay, so now we have something that looks like a color infrared photograph, but it's a satellite image. So add to this a polygon, sample polygons.shape. And these polygons represent aspen stands and Alaskan birch stands, and the aspen stands are infested with leaf miners. So we can symbolize our polygons by category and by text field. And then we'll make this a hollow, some aspen green color. And this one will make hollow some birch green color. And then just zoom to layer. Okay, so here is aspen polygons that are infested with aspen leaf miner. So basically, they're not bright red on the color infrared image, and these birch stands are not infested with the aspen leaf miner, so they're much healthier foliage and they're much brighter on the color infrared image. And here's an aspen polygon also, so let me make that double width. Okay, so what we're going to do is we're going to extract the 198 spectral bands from the pixels within the birch polygons compared to the pixels within the aspen polygons. So what we'll do is we'll make two layers, one representing aspen polygons and the other layer representing birch polygons. So for now, I'll just uncheck my Hyperion image, and I'll copy and paste to make a second layer. So then my first layer, I'll go to Properties, and I'll name this layer Aspen. And then I'll do a definition query. Is the text field equal to get unique values Aspen? So now these represent the aspen polygons. And then you would do the same thing for birch. So Properties, we're going to name this birch, and then do a definition query. So get unique values for my text field, is it birch? So here is the birch, and here are the aspen polygons. Okay, so now what we're going to do is we're going to cut out all the pixels inside the birch polygons and make one raster, and cut out all the pixels inside the aspen polygons and make that a second raster. So to do that, we can use the clip tool. So clip analysis is for cutting points, lines, and polygons, and clip data management is for clipping rasters. So we'll just run that clip tool. So I'm going to output to a new raster. I named it aspen hyperspectral.tiff, and I'm going to use the aspen polygons and use those polygons geometries for clipping. So this needs to be checked on. And then just OK. And that results in a raster for all these aspen polygons. Keep the pixels inside the polygons. So now we've got a raster called aspen hyperspectral.tiff, and you would repeat the process using the birch polygons, clip out the pixels inside those birch polygons. So once again, we have our hyperspectral raster we're going to cut from using our birch polygon, so we need to check this box on, use input polygons for clipping, and then just OK. And the result is a raster of the pixels inside the birch polygons. Okay, so then we'll use this tool, Band Collection Statistics, with our birch hyperspectral TIFF raster. Go to all those pixels that are inside the birch polygons and have 198 spectral values, and output that to a text file. So I called my text file birch polygon hyperspectral stats.txt. And then repeat the process for your aspen polygons. Okay, so what we're going to want to do is develop a hyperspectral curve for our aspen canopy, which was infested with the aspen leaf miner, compared to the birch canopy. Okay, so edit each text file so that basically the items are separated by commas. So for example, if I copy this and then edit, replace, so Control V to paste that tab with a comma, and then replace all. And just do that until you have all the spaces replaced with commas. So Control C to copy, Control V to paste, replace all. Okay, so once you have your text file separated with commas and properly formatted, all the way down to band 198, exit and then copy that text file. So Control C for copy, Control V for paste, and then rename that so it has an extension .csv, which will be an extension for Microsoft comma separated values. And then once it's renamed with an extension CSV, you can double click on it and it'll be an Excel spreadsheet CSV. So this would be for Aspen. And then the question will be, what spectral band had the greatest difference between the aspen canopy versus the birch canopy? So once again, the aspen was infested with leaf miner and the birch canopy was healthy. So if you go to the Blackboard website, there is a question comparing the aspen versus the birch canopies in terms of what was the spectral band that had the greatest separation between those two vegetation types, one infested with aspen leaf miner and the other healthy canopy.